Hello children, we are going to continue our exercise 3.3. Question number 11. Find measure angle C in the given figure if line segment AB is parallel to line segment DC. In the figure given, line segment AB and line segment DC are parallel. Then we can consider line segment BC as the transversal. So we can see angle B and angle C are the interior angles on the same side of transversal. We know that they are supplementary. That means their sum equal to 180. So angle B and angle C are the interior angles on the same side of transversal. So we can write measure angle B plus measure angle C equal to 180. So measure angle B is 120 plus measure angle C equal to 180. So measure angle C equal to 180 minus 120 equal to 60. So measure angle C equal to 60 degree. Next question is question number 12. Last question of that exercise. Find measure angle P and S if SP parallel to RQ in the figure. This is SP and this is RQ. These both are parallel. So we can consider SP and RQ are parallel. We can consider SR as the transversal. So we can see that here angle R is marked 90 here. So angle R and angle S are the interior angles on the same side of transversal. So their sum equal to 180 degree. So measure angle S plus measure angle R equal to 180 interior angles. So measure angle S plus measure angle R is given in the question 90 equal to 180. So measure angle S equal to 180 minus 90 equal to 90. Now we have to find measure angle P. The same way we can take PS and RQ are parallel and PQ we can consider as the transversal. So angle P and angle Q are the interior angles on the same side of transversal. Their sum equal to 180. So measure angle P plus Q equal to 180. Measure angle P plus angle Q is 130. Substituting, we will get measure angle P plus 130 equal to 180. So measure angle P equal to 180 minus 130 equal to 50. So we have measure angle S equal to 90 degree and measure angle P equal to 50 degree. Now we are going to learn properties of diagonals of different quadrilateral which we have learned. We have revised earlier, still we are joining all these together. First one is parallelogram. We know that diagonals of a parallelogram bisect each other. That is, in the given figure, AC one diagonal and DB another diagonal. Both will bisect each other at the point O. Second one, rhombus. The diagonals of a rhombus are perpendicular bisectors of one another. That is, as we told in the parallelogram, both the diagonals bisect each other at the point of intersection. Also at the point of intersection, they will make right angles. That is, they are intersecting at right angles. That is why they are called a perpendicular bisector. That is, angle AOB will be 90, angle BOC here will be 90, angle COD will be 90 here, angle DOA will be here 90. Next is rectangle. The diagonals of a rectangle are of equal length and bisect each other. Here in the diagram, AC is one diagonal and DB another diagonal. Both the diagonals are equal and at the same time they bisect each other at the point of intersection. Fourth one, square. The diagonals of a square are equal and perpendicular bisectors of each other. See the diagram. PR is one diagonal and SQ another diagonal. Both PR and SQ will be of equal length. At the same time, they bisect each other also and they are perpendicular bisector. That is, at the point of intersection, they will make a right angle. That is why they are called the perpendicular bisectors of each other. And last one is kite. In kite, the dotted line shows the diagonal. The diagonals of a kite are perpendicular to each other. That is, at the point of intersection, they will make a right angles. Now we are going to solve exercise 3.4. Question number 1, state whether true or false. First one, all rectangles are squares. It is false. All rectangles are not squares because in rectangle all sides are not equal. Second one, all rhombuses are parallelogram. True, because rhombuses follow the properties of parallelogram. See, all squares are rhombuses and also rectangle. It is true because square has all the properties of rhombus and rectangles. Next question, all squares are not parallelogram. False, because square following all the properties of parallelogram. E. All kites are rhombuses. It is false because in kites all sides are not equal. That is not true. That is one. F. All rhombuses are kites. True because rhombus follows the property of kite. G. All parallelograms are trapezium. It is true because trapezium, one pair of opposite sides is parallel. In parallelogram, both the pairs of opposite sides are parallel, so it follows the property of trapezium. Last question, all squares are trapezium. It is true because square has all the properties of trapezium. Now question number 2, identify all the quadrilaterals that have, question number 1, 4 sides of equal length. We know that in rhombus and square all 4 sides are equal. Next one, 4 right angles. We know that rectangle and square have all the 4 angles, right angles. Next, question number 3. Explain how a square is, first one, a quadrilateral. We know that square is a closed figure with all 4 sides. So it is a quadrilateral. Second one, how square is a parallelogram. Square is a parallelogram because both the pairs of opposite sides of a square are parallel. Therefore, square is a parallelogram. Next, how square is a rhombus. Square is a parallelogram with all 4 sides equal. Therefore, square is a rhombus. Next, rectangle. Square is a rectangle because square is a parallelogram with all the 4 angles are right angles. So it is a rectangle. Next, name the quadrilaterals whose diagonals bisect each other. We learned the properties of diagonal. Diagonals bisect each other in parallelogram, rhombus, square, and rectangle. Next, diagonals are perpendicular bisectors of each other. That also we learned just now. In rhombus and square, diagonals are perpendicular bisectors of each other. Now diagonals are equal. In square and rectangle, diagonals are equal. Question number 5. Explain why rectangle is a convex quadrilateral. A rectangle is a convex quadrilateral because its diagonals, both the diagonals lie in its interior. Now we will move on to last question of this lesson. ABC is a right angle triangle and O is the midpoint of the side opposite to the right angle. Explain why O is equidistant from point A, B and C. Here triangle ABC is a right angle triangle given. O is the midpoint of side AC. And for solving this sum easily, one hint is given. The dotted lines are drawn additionally to help you. So if you join the dotted lines, we will get a rectangle ABCD. So if you complete the figure with a dotted line, then ABCD becomes a rectangle. So we know that in rectangle, diagonals are equal and bisect each other. So we have AO will be equal to BO will be equal to CO. So we can say that O is equidistant from A, B and C. With this, we will come to the end of this lesson. All of you, I think all of you are copying all these sums which we have solved here. Continue it. Thank you.